This lesson's on photoperiodism in plants and specifically control of flowering. Here are the objectives. Photoperiodism refers to physiological responses to day length, and an example is the control of flowering. Plants can be divided into several groups. Short day plants are plants that flower when the day length is short, whereas long day plants are plants that flower when the day length is long. And there are plants that are neutral that don't care what the length of the day is. So if this bar here represents a 24-hour cycle, then if you're in the more like the winter months where there is a lot of nighttime, indicated here by this shaded region. So this is the night, a period of darkness, and this is the day when you have a period of light. In a situation like this, then a short day plant would flower, but a long day plant would not. In contrast, if you had a much longer period of light in the 24-hour cycle and a much shorter period of dark, then now a short day plant would not flower, but a long day plant would, again because you've got this long period of light and a short period of darkness. So what's going on here? What are the plants actually detecting? Well, we can do some further experiments. Imagine that we took this kind of setup with a long period of light and a short period of dark. So we're going to replicate that again. But we interrupted the daytime with a period where there was darkness. So for example, we had this in a controlled environment where we could control the light, and we switched off the lights here. Well, what happens in this case? Turns out that this makes no difference from the previous situation. The short day plants still do not flower, and the long day plants do. So there's no difference between these two situations. But now if we go back to this kind of situation where we have a long period of darkness, and now we interrupt the long period of darkness with a flash of light. So again, what we're doing here, we have this controlled environment, and then at a point during the night, during the period of darkness, we're flashing a light, and then we're switching the lights back off and allowing more darkness. Well, it turns out that in this case, the long day plants actually do flower. The plants detect this as a continuation of the day, and in contrast, the short day plants do not. So by interrupting the period of darkness with a period of light, we've tricked the plant into thinking that this is a long day. So it turns out that what the plant is actually detecting is the night length, the uninterrupted period of darkness. And when the darkness is interrupted by a period of light, the plant detects it as if it was continuous day. So here, the plant is experiencing this as if it is one long continuous day, just like here. Underlying this is the fact that plants are using a pigment called phytochrome to detect the presence of light. And phytochrome changes back and forth between two different forms, one that it turns into in the presence of light, and one that it slowly reverts back to in darkness. So in this case, this flash of light is converting the phytochrome back into the form that tells the plant, hey, it's daytime, and therefore it's treating this as one long day. So even though they're called short day and long day plants, what the plant is actually detecting is the length of the night, the length of the uninterrupted dark period. If you interrupt the dark period here with a flash of light, the phytochrome detects that, tells the plant that it's still daytime, and therefore the plant thinks that it's still a season where the days are long. And then that will affect things like gene expression, which will control flowering. So that's a very quick introduction to photoperiodism in plants.